The Airbus A350, the most advanced commercial aircraft in the world. Its construction, nothing short of a masterpiece, on the grand scale and down to the smallest detail. 2.5 million components, 1,800 professionals for the final assembly alone. Together, constructing an aircraft the likes of which the world has never seen before. The goal, minimal fuel consumption, maximum range, the product of precision workmanship, expertise, and quite simply, pride. And all this is only possible thanks to perfect mega manufacturing. Toulouse, France, the headquarters of Europe's largest aircraft manufacturer. In Blagnac, Airbus workers construct the most advanced passenger aircraft in the world, the Airbus A350. 1 o'clock in the afternoon, one of the fleet of Beluga transport aircraft arrives with a delivery of components, so called because its shape resembles that of the white whale. It is key to the construction process. A 1,500 cubic meter cargo compartment and a 47 metric ton payload. An entire fuselage section of the A350 fits in the belly of a single Beluga. Or, as in this case, one of its wings. Measuring 32 meters in length, it would be practically impossible to build the A350 without the Beluga fleet. Baptiste Dronet must see to it that his team unloads all the freight within an hour. Every delay triggers a chain reaction, disrupting construction of the world's most advanced passenger aircraft. Unloading the unique Beluga super transporters is Baptiste's dream job.
I'm very proud of our Beluga fleet. They're key to the entire assembly operation running smoothly. I've loved planes since childhood. My father and my grandfather worked at Airbus. Our family has always been fascinated with aviation.
The Beluga fleet flies wings, fuselage sections, cabin furnishing, and vertical tailplanes for the A350 from around Europe to these assembly hangars in Toulouse. 4,500 suppliers and 12 Airbus facilities are involved in its production. The background behind this complex puzzle? Airbus was established in the 1960s as a consortium of companies from across the European continent. Different locations have different areas of expertise to this day. Of particular importance to the production of the A350 are the sites in France, Spain, Germany, and Great Britain. The nose and midsection come from the Saint-Nazaire plant, the tail section from Hamburg. The wings are manufactured in Broughton and Bremen, the horizontal tailplane in Getafe. All of these shipments must be perfectly coordinated. Head of the unit, Nabil Tahiri.
It's our job to ensure that all the parts are transported on time. We have to always make sure that all of the components are on hand here. Thanks to our fleet of transport aircraft, we can get anything that's missing here straight away. We need around 3 hours to pick up a part from anywhere inside Europe. The Beluga provides us with an extremely quick and safe way of getting all the parts we need in a timely manner. Our system is absolutely reliable.
Even when everything is running smoothly, the A350 still has to go through 7 stations. With 120 aircraft a year, this demands absolute perfection. Everything begins in Station 59. The first stage of the final assembly line. Around 40 workers fit out the fuselage with the large components of the passenger cabin, such as the galley and washrooms. 9 such fuselage segments can be worked on in parallel here. Responsible for this work is François-Louis Godin. He oversees each machine for 80 days, from the first assembly step to completion.
This is where assembly begins. The sections of the A350's fuselage arrive here from all over Europe. We work on outfitting the passenger cabin from the very first station to the last station. What makes this assembly line unique is that we fit out the passenger cabin and assemble the aircraft in parallel. This change to the workflow allows us to minimize production time.
6:30 in the morning. Team briefing at the start of the shift. 15 workers, mostly electricians and installation technicians, divide up the day's tasks amongst themselves. They have to install the galleys, washrooms, and crew rest compartments. Any special requests from the airlines are incorporated here too. The outfitting work is performed on all fuselage sections in shifts. This way, no team has to wait for another. In the tail section of a future A350, 2 workers make preparations for the installation of the galley. Assembly instructions individually pack screws. It all resembles a bit like a flat-pack wardrobe from a furniture store.
It's not as simple as it looks. It's very different to screwing together an IKEA bookshelf. That would be great, but it isn't like that, unfortunately. It takes highly trained craftsmen. Even the smallest of installations can affect the safety of the finished aircraft. As such, special expertise is required for every single operation. It takes months and often years to train our workers.
In contrast with a cupboard from a furniture store, it's critical that nothing can shift, even during the most severe turbulence. No screw may fail. A big responsibility for the workers. Just as it is for the quality inspectors in the adjacent fuselage section. They have to first approve the delivered fuselages for outfitting, but only if every bulkhead, every electrical component, and even the floor is free of defects. The supplier has already ultrasonically inspected it for damage on departure, but a lot could have happened during transport, and nothing can be left to chance. The next fuselage has already been released. Craftsmen seal the floor where the lavatory will later be installed. The film prevents moisture from penetrating the floor. Like everywhere in the aircraft, there are electrical cables there too. And there are more of them in the high-tech A350 than in most other commercial aircraft. There are instructions for every task. Each worker must double-check that the work has been performed to the exacting standard. In the first hangar, the teams install components that would no longer fit through the doors once the fuselage is assembled. A resting cabin for the pilots arrives. The Airbus crew installs it behind the cockpit and above the galley. The A350 is a long-haul airliner. It can fly non-stop for up to 20 hours. There are several pilots on board for such flights who take it in turns to rest. Work on the fuselage sections continues without a break. They are, after all, expected to fly away soon. Next up is Station 50 of the final assembly line. The fuselage sections are now ready for their big moment, the so-called marriage. Waiting at Station 50 are Deputy Unit Head Arnaud Herry and Team Manager Wilfried Martin. They have the nose section for an A350 maneuvered into the hangar. Arnaud has worked at Airbus for 16 years and on the A350 final assembly line for 6 of these. The aircraft is very popular. Over 250 of them have been delivered to date, and there are orders for a further 890 on the books. With this number of outstanding orders, every stage of production is subject to an extremely strict timetable.
Because of the number of parts that have to be assembled to build an aircraft and the large number of subcontractors, partners, and factories that supply them to us, there are a whole host of risk factors. We often have to set priorities in order to ensure that the aircraft arrives at the next station on time. We sometimes allow work that has not yet been finished to be completed at the next station. Our overriding priority is to avoid at all costs the next station being prevented from continuing with the assembly work.
Once the nose section is in place, the transport operator maneuvers the middle section into the hangar. Both sections are already equipped with lines for the hydraulic, water, oxygen, and air conditioning systems. They are already insulated, and wiring harnesses are installed under the ceiling. The tail section waits in front of the hangar. In the case of the A350-1000, the three fuselage sections together measure 73.8 meters in length, 7 meters more than the shorter version. The operators align the fuselage sections with 1/10 of a millimeter precision before they join them together with around 40,000 fasteners. As with the rest of the construction, most of this work is performed by hand. Over 10,000 rivets hold the carbon fiber fuselage sections together. No other aircraft uses such a high proportion of carbon fiber as the A350. Because the material is extremely hard, the workers have to use especially high-quality drilling equipment. 53% of the A350 is composed of carbon composite. It's 40% lighter than aluminum and allows much more complex shapes. Each layer consists of super thin plies of carbon fiber, embedded in a synthetic resin matrix. And there are several layers, a process that takes a few days. In the aviation industry, composites are viewed as the materials of the future and are increasingly replacing aircraft aluminum. The aircraft is fitted with its iconic nose gear at this station, all in parallel with the myriad other processes taking place. This component alone is constructed from around 1,000 parts, primarily made from high tensile steel. It too is installed by hand. Every connection is bonded and bolted for safety. Following installation, the workers check the functionality of the landing gear. It's activated by remote control instead of the pilot pressing a button. The nose wheel must deploy at the same speed it would during approach. The nose gear is now operational. The A350 fuselage must again switch hangars to be fitted with its main landing gear. The workers hydraulically lower the 32-ton fuselage to rest on its support wheels. A big moment. The fuselage of the wide-body jet will soon leave the hangar in one piece.
Despite the routine, you're always learning something new, whether at a personal, technical, or organizational level. You start each day in good spirits, happy to be building these amazing cutting-edge products. It requires total dedication at all times from everyone.
De la technologie et qui demande un engagement de tous au quotidien.
The massive fuselage rests on its wheels for the first time, and everyone holds their breath. The operator of the aircraft tractor grabs the nose wheel to carefully push it out of the hangar, just like maneuvering around the airport. After being joined up at Station 50, the cigar, as it's affectionately known, continues on its journey. A cigar is what an assembled fuselage without wings is called in aviation jargon. These will be fitted at the next station. The next hangar, known as Station 40, can accommodate 4 cigars at the same time. They'll be almost complete aircraft when they leave. The aircraft will be 90% finished when it leaves this station. Wings, main landing gear, tail assembly. The specialists here attach everything visibly missing from the outside of the aircraft. To maintain efficiency, several teams work in parallel at this station too. A crane lifts the wing into position that will later support the aircraft in flight. The 32-meter long and 6-meter wide wings are the largest aircraft components ever to be fabricated from carbon fiber composite material. The wings of the A350 are something very special. Their development was painstaking and contained over 4,000 hours of wind tunnel testing. Positioning them is an incredible feat too. Several thousand rivets will now keep the wings attached to the fuselage at speeds of up to 960 kilometers per hour. Flap design is optimized to reduce vortex generation, resulting in better lift efficiency and improved low-speed performance, while reducing aerodynamic generated noise from the wing. A special droop nose is integrated into the inboard wing leading edge. It helps the aircraft remain flyable even at low airspeeds. This facilitates takeoff and landing. Like the wing, the horizontal tailplane of the A350 is made from carbon too. It has a span of 19 meters and was manufactured in Getafe, Spain. As with the fuselage segments and the wings, all of the electrical and hydraulic systems have already been installed. The vertical tailplane comes from Stade in Germany. It's the only component that is painted prior to installation due to its eventual height. The main landing gear of the A350-1000 consists of 2 6-wheel bogies. During landing, it has to support a weight of up to 233 metric tons. Following installation, Florent Cubereau and his colleagues connect the hydraulic lines that control the landing gear. A combination of adhesive and bolts is used here as well. Florent hasn't always worked on landing gear. He used to be a bricklayer before he applied for a job at Airbus.
I come from Toulouse. Airbus is the biggest employer here, and they started this new program with the A350. They were recruiting workers, so I decided to try my luck at Airbus. After the interviews, I was given training and passed the exams. Then I was assigned here to Station 40.
Airbus is not only the biggest employer in Toulouse, aircraft construction is pretty much a part of the regional identity here. The scale of the facility is truly impressive. 23,000 people work for Airbus in the hangars and offices surrounding Toulouse-Blagnac Airport. They work 5 days a week in 2 shifts. Lunchtime is staggered. The early shift workers go to lunch first, then the office staff. The cooks working in the 15 restaurants around the factory site prepared 2.6 million meals each year, handling 13.5 tons of steak and 10.5 tons of salad in the process. There are 20 company bus routes operating on the Airbus site. They transport 800,000 passengers each year. Anyone traveling to work with their own car can expect to be subject to strict controls. The site traffic monitoring service takes adherence to vehicle controls very seriously. No one is allowed to drive faster than 30 kilometers per hour.
A white Renault, 43 kilometers per hour.
Okay, understood. I'll intercept it.
Those violating the traffic regulations risk losing permission to enter the site.
Hello, sir. I'm from site security. Can you switch your engine off and show me your ID and parking permit, please?
Another citation means suspension of the parking permit.
You can use this to pick up your parking permit in 8 days' time. You have to go to gate B to get it back. Have a good day, sir.
Those who persistently violate the rules lose their permit permanently. Back at Station 40. Work continues after lunch, while wings, landing gear, and tail assembly are being mounted to the outside. Specialists are inside the plane, outfitting the cabin. Installing the cabin interior in parallel to assembling the aircraft is new. This change alone has reduced construction time by 1/3. Francois Louis, head of cabin installation, makes sure that there are no delays with the installation.
We previously saw the start of assembly, when the large components are installed. Everything that wouldn't fit through the cabin door later, once the fuselage is joined together. Here we're installing the so-called floor-to-floor. The wall lining, overhead compartments, and also the safety components, like the signals for cabin crew and passengers, and the overhead units that contain the oxygen masks.
Les messages aux passagers, ainsi que les boîtes à oxygène dans lesquelles sont stockés les masques à oxygène.
The cabin functions are regulated by a central control unit. In the A350, it ensures 20% higher air humidity and higher cabin pressure than has been usual until now, making it feel a lot closer to normal life on Earth. While the interior is being installed, a worker is in the cargo hold with a rag and brush. Cédric Cabarros.
I have to clean this area here before I fix the insulating material in place. Whatever is underneath it will no longer be visible or accessible. Any residues, like a metal swarf or other dirt, that could be hidden behind it must be removed. Only when we're absolutely sure that this area is pristine can we lower the lining and fix in place the insulation between the exterior and interior of the aircraft.
Pour avoir cette isolation thermique entre l'extérieur et l'intérieur de l'avion. Voilà.
There are some traces here, for example. I use a cleaning cloth with a special solvent for this. There's something here too. Now I'm sure everything is clean, and I can close up the insulation.
The big moment for the entire team at Station 40 arrives. Their aircraft will rest entirely on its own wheels for the first time. Everything must be perfectly clean. No work residues, no drop of oil is allowed to contaminate the brand new aircraft or its tires. The workers activate the hydraulic system. They lower their over 100-ton creation. It's an emotional moment for everyone, including for Arnaud.
You could say it's like the end of a pregnancy, a kind of birth. But there's a birth at a station every 8 to 9 days. Over time, that's an awful lot of babies. There's a part of us in every plane. We all put a lot of energy and dedication into our work. It makes us very happy to have done our bit.
Arnaud's colleagues check the tire pressure under the load of the aircraft's weight.
16-4.
The aircraft is about 90% finished. It's time to bid farewell to Station 40. The doors open for the station's latest offspring to enter the world.
Building aircraft is a real pleasure and is something I'm proud of. This is matched by the great sense of responsibility we feel when later our families, our children, or friends climb aboard. So we're committed to doing a perfect job every day, never overlooking anything, and building aircraft of the highest quality. And it's true, you can't help being filled with a certain pride each time you see one of these huge machines flying away.
Everything is ready for the big moment. The openings in the machine are covered to protect against rain before the aircraft is moved to the next hangar. This new A350 will soon be flying for China's Southern Airlines. Millions of people will be putting their lives and their trust in the work performed by Arnaud Herry and his team. $2.5 million individual parts are installed in an A350 when finished. And they all have to be present, of course. Not even one part can be missing. Airbus gathers together the parts for its aircraft at 2 logistics centers. Stored on an area totaling 84,000 square meters, the equivalent of nearly 12 football fields, are aircraft parts and everything needed for the cabin interior: galley, overhead compartments, toilets, and seats. "50 different airlines have ordered the A350. This means 50 different interiors for business, economy, and first class. The logistics specialists supply the components to the assembly hangars as and when needed. This just-in-time process requires precision in supply and demand. David Gaillard is the head of the Airlog Center. He must be aware of what parts are needed at all times. If just a single curtain is missing, the aircraft cannot be delivered, and the entire production line grinds to a halt. Bearing in mind the number of outstanding orders for the A350, a disaster, David tries to avoid delivery bottlenecks and delays by way of stock keeping.
Airbus's strategy involves looking to see where the greatest expertise in a particular discipline is located. This is why we work with many factories in Europe, and indeed throughout the world too, if you include all of our subcontractors. The logistics are highly complex, and that's precisely the challenge our department faces. We coordinate everything and take delivery of parts from all over the world that arrive by plane, train, ship, and of course by road too. We're talking about 40,000 deliveries a week.
On parle de 40,000 réceptions par semaine.
And every single delivered item is checked and logged by David's staff. If any part turns out to be damaged, his team immediately organizes its replacement or repair. Components for the A350 arrive on a near daily basis by plane too, 7 days a week, from early in the morning until midnight. And then there are the machines waiting to be delivered. Airbus has its own tower in order to coordinate all these flights for the factory in Toulouse. The air traffic controllers don't just monitor the air traffic. Alexandre Clavier has an overview of the entire factory site on his monitors. He also coordinates the movement of aircraft between the hangars. Every machine to be maneuvered from one station to the next needs his approval and clearance. Alexandre and his colleagues have to coordinate 50 aircraft movements each day, and that doesn't even account for the rest of the site traffic.
Fox, Whiskey, Whiskey, Bravo, Charlie. Okay, cleared for takeoff after the fire truck.
Roger, we're pushing back. Cleared for takeoff. Bravo, Charlie.
Airbus shares the runway with the public airport at Toulouse-Blagnac. Alexandre's team also coordinates the cargo flights with the tower there. A Beluga XL, the prototype for an even larger transport aircraft, has just landed.
Airbus 42X Lima, roulé Whiskey, Sierra 32, Zulu unité pour Pierre 8.
The existing Beluga fleet alone clocks up over 10,000 flight hours each year.
We coordinate 2 types of flights, those of the development department and those of production. The ones for the development department are prototypes. The flights for production are aircraft destined for customers, for example, that are being delivered to airlines. 2 air traffic controllers are always on duty at the same time. The air traffic control officer responsible for the frequency controls the air traffic in real time. And we also have a coordination officer who is in permanent contact with the tower in Blagnac and the flight test center in order to get takeoff clearance for the pilots. He organizes the takeoffs.
The
Airbus A350 reaches Station 30. The lower the number, the closer the aircraft is to completion. Francois, head of cabin installation, checks the fittings of the business class seats. Quality control has done its job and identified minor defects. The inspectors have discovered problems with the movement of the seat backs. An expensive business class seat is expected to function flawlessly. High travel comfort is an important component of modern air transport for Airbus, the airlines, and for the increasingly discerning passenger. Airbus promises A350 passengers higher levels of comfort in all classes. Seats, lighting, cabin pressure, and cabin noise levels have been significantly improved. The noise level, for example, is 4 times lower than in comparable aircraft, a benefit that mustn't compromise quality in other areas.
Lorsqu'il arrive à cette station, nous installons tous les sièges.
At this station, we install all the seats from economy to business class.
Donc la première étape, c'est de rentrer le siège dans l'avion, de l'installer.
Colleagues from the quality control department check whether the seats have been installed properly. If necessary, defects are rectified by the seat manufacturer.
Puis nous avons éventuellement des reworks qui sont faits par nos partenaires qui fabriquent les sièges.
While the remedial work is going on, another team installs the seats in economy class. The fuselage of the A350 has an especially large diameter, hence the suffix XWB, which stands for extra wide body. In its standard configuration, the A350-1000 can accommodate 366 passengers, but it's also possible to fit 10 seats per row. This would allow the aircraft to carry as many as 440 passengers. Claire Sescon is the deputy head of Station 30. She supervises and coordinates 30 electricians and mechanics who perform the preliminary function tests and take care of small repairs at the same time.
Bonjour.
Bonjour.
Tu vas bien?
Ça va et vous?
Ça va. C'est bon? Tout avance comme tu veux?
Ouais, c'est bon, on va monter ce panneau là.
Ok, parfait.
In contrast with every other assembly line at Airbus, the mechanical and electrical systems of the A350 are worked on in parallel.
It is a great responsibility to take care of the safety of the employees and of the aircraft, especially here at Station 30, where different departments work simultaneously: quality control, production, and testing. The key to our successful work lies in the harmonious cooperation required to build the aircraft on time, to the highest quality, and to everyone's safety.
There are specialists for every task, however minor.
Will this be ready soon?
Yes, the specialists will drill the holes shortly, and then we can carry on.
Perfect. Super. I grew up in Toulouse, so I always saw planes and watched the maiden flights. The residents of Toulouse have always been surrounded by aviation. For me, working here was a dream from an early age.
Today, Claire supervises how workers here at Station 30 add the finishing touches to the A350. The workers, for example, close the last gap between the fuselage and the wing at the side of the aircraft.
528, 488.
In the cargo hold, electrician Cédric Lomond is testing the cabling. 180 kilometers of cable are installed in every A350. Keeping track of everything here is a complex undertaking.
In position now.
Okay, I'm ready. Okay.
Connected to ground.
The electricians test every single cable in the aircraft. All the systems are still accessible, for now.
We're testing the cables. This involves increasing the voltage in order to find out if the resistance is high enough. These are the cables that control the engines.
After the test, Cedric's colleague seals off all the connectors again. No dirt can be allowed to get into this sophisticated control system. All of the cables that the pilots use to control the aircraft's functions converge in front of the cargo hold below the cockpit. Safety-related systems are installed in duplicate for redundancy. Specialists inspect every single cable connection here too, irrespective of how difficult they are to get to. They're always conscious of their responsibility. Any mistake that electrician Nicolas Vernier makes now could have fatal consequences.
This is where the electronic control systems are located, the heart of the aircraft, as it were. When doing my job, I often think about all the passengers who'll board this aircraft someday and set off on their travels with complete confidence.
Once all the function tests have been completed, the aircraft moves on to the penultimate station, Station 20, where its engines will be fitted. The A350 is powered by two state-of-the-art turbofan engines, developed exclusively for this aircraft by Rolls-Royce. It's the most fuel-efficient commercial aircraft engine in the world, the Trent XWB. The engine specialists hydraulically raise the massive turbine up to its mounting points below the wing. They bolt the 8-ton, 50,000 horsepower engine to the aircraft wing using just two mounting brackets. The massive turbine consists of more than 20,000 components, most of them fitted together by hand. Once the turbine is secure on the pylon, the hydraulic transport vehicle is lowered back down. A single turbine costs almost 32 million euros, so great care must be taken when maneuvering. Each of the two engines generates 374.5 kilonewtons of thrust. Each turbine consists of 22 titanium blades and has a diameter of nearly 3 meters. During takeoff, the engine takes in over a metric ton of air each second. Rolls-Royce uses state-of-the-art ceramic coatings inside the combustion chamber, because in this turbine, the air-fuel mixture burns at extremely high temperatures, in excess of 2,000 degrees Celsius. The upshot? Around 15% lower fuel consumption and significantly better emission levels than its predecessor. In addition to this, Trent XWB engines are much quieter than any other aeroturbine, essential for planes flying over heavily populated conurbations. Before Airbus shipped the first A350 in December 2014, aircraft and engines were subjected to extensive stress tests under extreme climatic and weather conditions that the aircraft would not have to endure during normal operation. Back at Station 20, cabin integrator Laurent Barateau sets about making the last few minor adjustments. Everything must be just right and adhere to the highest standards to ensure acceptance by the customer. Every reading light must be angled properly. No scratches must be allowed to ruin the impression. The list price of an A350-1000 is almost 330 million euros. So the customer understandably expects to receive a first-class product.
At this point, we examine everything again very closely and place great emphasis on protecting the cabin, as all the elements are very expensive. If you install them, you should avoid damaging them, as several jobs are always being performed inside the aircraft at the same time. Everything has to be well protected. Unfortunately, however, we sometimes find some damage, or we discover during testing that a seat doesn't work properly. Then we have to rectify the issue.
Just a couple of days until completion. Time for the plane to receive its paint job. The painters apply 5 coats of paint. A polyurethane paint with low volatile organic compound content. That's better for the environment and the painters. The spray guns use an electrostatic spray system. They distribute the paint extremely evenly, thus reducing paint consumption and aircraft weight. After 4.5 months on the final assembly line, a new Airbus A350 is finished. Finally, the pilots take over, and this marvel of modern engineering can take to the skies. 10 aircraft of this type take off on their maiden flight each month. Soon, hundreds of them will be connecting continents and millions of people as they are carried to their destinations worldwide. And as they do, they'll be flying on the most advanced passenger aircraft in the world, the Airbus A350 from Toulouse.